So what I heard when I joined was, let's talk like something about not flat earthers, but it's like I really feel like that's relevant to the whole, flat Earth thing. Like that's the name of the channel.
Well, I can see why you'd say that,
Yeah,
but
yeah.
what we're meaning is we're
Mhm.
talking about the physical nature of the earth, the surface
Yeah,
beneath
yeah.
our feet, right? So it
Mm.
what we do for a living or what we enjoy doesn't really have any bearing on how the earth is observed and measured. So that's really what we're talking about. But I was
Yeah.
going to ask you, so what have you heard about flat earth so far? Do you know what our positions are? Do you know what our arguments are, or do you not know those things yet?
Pretty generally, I mean, I wouldn't be able to directly tell you. I've seen some of the tests you guys have done to like see if the Earth is flat regarding like the I think it's checking the horizon and seeing how like shadows.
So yeah,
Yeah,
that's
for
one of the
sure.
things.
Yeah.
One of the things we're doing is testing to see if the surface that we live on has the curvature that matches what the globe model claims.
Yeah.
So,
Psyclone, can you explain a
do you
little
know
bit
of
about the
any?
testing you've done
Anon, put yourself
personally?
on mute. We've got a coherent person in now.
Okay, but what testing did you do? I mean, it's important, no?
Yeah, well,
Before we get into it, take
we can
time.
go through long distance observations and all that kind of stuff. But first, we need to set the stage and understand that you understand what the actual globe model is claiming. So,
The
NerdNet, have you
globe
ever
model.
looked
I thought you'd tell
into?
us about the flat.
Anon, we're not talking to you now. Someone put this guy on mute if he's not going to shut up. No, have you ever looked into the claimed curvature of the Earth, the globe?
Not
You know much about that?
particularly. No, no, I haven't. No, you can educate me there.
Okay, so do you know what size that they claim the globe is, roughly?
Yeah, no, I wouldn't be able to give you the number. No, I wouldn't.
Okay, so they say it's got like a 59 mile radius, 25,000 circumference in miles. So they give us a size, right? So
Yeah.
if you have the size of a ball, you can do some maths to work out what the curvature rate should be. It basically works out to around 8 inches per mile squared.
Hmm.
So
But does that
over
account for like uh, like you could be at sea level and then there's like mountains and
No,
like
that's
it's
just
not exactly a
geometric.
smooth
Yeah,
ball.
yeah, yeah. So that's just
Yeah, yeah.
geometric curve on the surface. If you're an observer, then you need to take into account your observer height, right? So you can
Yeah.
see a bit
Hmm.
further if you're going higher up, which is the case on a flat surface too. So
Yeah.
if you go on Google, you can type in like distance to horizon calculator, and you can put in your observer height, and it will tell you how far away the horizon should be based on your observer height. So, say for a 6 foot observer, they're telling us that for a 6 foot observer, if you were standing at the beach looking out over the ocean, the horizon should be no more than 2.5, 3 miles away, right?
Yeah.
Okay, so that would mean that if you were standing at the beach and you were watching a ship going out at 2.5, 3 miles, it would have to start disappearing bottom up, going over the curve, which is showing itself as a horizon. Yeah.
Yeah.
But what's happening is people are going and testing this, and they're seeing the boat go 5 miles, 10 miles, 15 miles, 20 miles, 30 miles, and it's not even reached the horizon, right?
Yeah.
So how would that work if the horizon is this physical Earth curve? I mean, that's set in stone if that's real. There's no getting away from that. And yet, when people go and test that, it's not detected. Right? The horizon isn't where it's supposed to be. You understand that?
Yeah. I get what you're
I mean,
saying.
obviously, I'm just telling you that now. You don't know because you've not seen any of the examples. I'm sure people can post in the side chat. They'll post some examples, and what we recommend is that wherever you live, you go and test this because it's as
Yeah, I mean,
simple
I'm
as.
in Florida, man. I've seen
Oh well, there you go.
boats go over the horizon. I'm at sea level. I'm pretty close to the ground.
That's
I'm a
a
grounded
lie. That's
person.
a lie, dude.
Well, this is
What? It's a
perfect. No,
lie that I'm
because
in Florida?
no. Don't hold on, Radwin. No, because he
No, I'm
might
just confused. What
thinks
what
he's
about
seeing
I said was a
he's
lie?
seeing boats going over the horizon. That's fine. But
Yeah.
I bet what you but the thing that we don't do when we see that is we don't compare it to the globe model and actually check that matches, right? Because I bet when you've seen them going over before, you've just thought, oh well, it's going over the curve, but you've not actually thought, wait, what's my observer height, and what distance should that horizon be? Am I right in saying that?
I guess you are. Yeah. I mean, I
Yeah,
wouldn't
so
have.
now the next time, what you should do is you should take note of what your observer height is above sea level and what the conditions are of the day, temperature, and things like that. And you should actually really in detail examine what it is that you're seeing. So, how far away is the boat? What's your observer height? And then does that match the globe model, which you can find just by going on the calculators online, right? And
Yeah.
what people are finding is that it does not match. That physical curvature that has to be there for it to be a ball is not there. So we're seeing distances way in excess of what we should be able to see, right? The curvature should be stopping us seeing any, like beyond a certain point, right? But it's not. We're just seeing beyond it. We're seeing boats and buildings and people and things that should be on the other side of a curve, but we're seeing them. Okay, so that's basically like the main argument being made here is that it can't be the globe that they're telling us because all of the observations and the measurements are showing that there's no curvature. Now, that doesn't mean that we're making a claim as to what the entire thing is. Like, we're not saying it's a disk in space or a square in space. We're not actually saying it's anything in space because we don't actually accept that that solar system model that they've shown us is actually true to begin with. But yeah, we're not actually making a claim about the exact geometry of the Earth because if you think about it, you'd understand that you couldn't actually know that as a human being on Earth. I mean, unless you had everyone like exploring it and finding some limit of it and then actually mapping the entire thing out, which none of us can do. Yeah. So that's maybe a lot. Do you have any questions?
I just feel as though because I do get where you're coming from there. And I think there will
Mhm.
always be like some degree of a disparity because in like you said, measuring how far boats go out and whatnot. Like I feel like
Mhm.
I feel like that is a somewhat difficult thing to measure. I mean,
Well,
boat travel and
it's not
whatnot.
necessarily super simple, but it's pretty doable. Like, because nowadays
Yeah, yeah.
you've got websites that track boats, so you can see how far away a boat is from the coast. You don't just have to use boats, right? One of the common examples that's used here is something like an oil rig, like a fixed platform. So we know the distance that it is away from shore, or like a wind farm, like wind turbines out at sea,
Yeah,
things
but
like
then you got to
these
do that
fixed
account for the
platforms.
height.
Well, no, because if you're trying to see how much of that object is blocked, then yeah. But as it comes to the horizon, you just use these objects as a distance marker. So, say for example, an oil rig is 10 miles away. You can just see whether the horizon appears in front of the oil rig or behind it, and that will tell you at least whether the horizon is closer than 10 miles or further than 10 miles. Yeah.
Yeah.
So it's true what you're saying. It's not like a super mindless task to do something like this. You do have to put a little bit of thought into it, but it's very doable, right? It's a lot more doable than, let's say, go to space, like a lot of people try and say, like, oh, I'd have to go to space to know. No, you just have to go to like a large body of water or a salt flat or something, and you can start testing the claimed curvature of the globe. And what we're finding is that it doesn't exist. It's not measured.
What's then?
Which
What's your opinion on like gravity? Because that the something about the flat Earth argument that I've seen is that like how do you feel that everything like stays? Do you think it's like a plate in a way where it's or like a bowl?
Well, we've
Like
got like our
how
own.
does
I
the
would say
water?
we're all on the same level. Well, okay, now you're all right. Maybe I
Yeah.
don't know what question you're going to ask because I thought you were going to ask about gravity and why things falling, but now it sounds like you're asking how's all the water contained or something like that.
Well, that does tie into gravity. I mean
Okay, so you're
the
looking for both.
general. I mean
Okay,
the whole globe thing is like that.
I'll give you
You know.
my general take on it, right?
Yeah.
So
Yeah. Go ahead.
what we know about a body of water, let's say a lake, it
Yeah.
has a shoreline, right?
Hmm.
Every standing body of water has a shoreline where there's land that's higher than the water, which keeps it contained. And that's the physical property of water. Unless it's like a river and it's just running, like any like standing body, like a lake or something, has a shoreline. I mean, even the rivers, if they're not going to overflow their banks, they have a shoreline, so or like a bank. So it would make sense to me that the world's ocean, which is what we have one large contiguous world ocean, which is, broken up into separate sections and people give them different names, but it's essentially one body of water. It must have a shoreline to keep it contained. Now, where that is and what it looks like along its total area, none of us know. I don't know if anyone knows. I doubt they do. But
Yeah.
that's the only reasonable explanation that I could put forward because that's what all water does. That's how all water behaves. Yeah, it needs a shoreline. So eventually, if you were to carry on through the world's oceans, I would say you'd have to come to a shoreline of some kind where the land is higher than the water, keeping it contained. Now, as it comes to gravity, they've pulled a fast one on us by making us associate the word gravity and the phenomena of objects falling down with a ball Earth, when in reality there's no logical connection. Right? I can drop my phone on the floor and not know that I live on a ball. Right? I could just as easily drop my phone onto a flat surface. And what we appear to observe without saying that this is the exact cause, because no one actually knows what the cause is. It's kind of like a passive effect in a video game, right? Like gravity's been coded in, but
Yeah.
to pull it apart, you can't turn it on and off. You can't stop it. So it's hard to, you can't really do science on it. You can observe it and you can test it and you can say it does this and things fall like this, but you can't really say this is what the cause of it is because you can't pull apart a causal mechanism. But I'd say what we can observe and test is that there's a relationship between the density of an object and the density of the medium that it's in. And when an object is more dense than the medium that it's in, it will descend towards the surface, the floor. And when it's less dense, it will rise. So a rock being more dense than air will fall in air. It will sink through the medium. Whereas a helium balloon, because helium is less dense than air, will rise. So things seem to be ordering themselves relative to a flat, motionless plane based on their density relative to the medium density that they're in. So that's what I would say we can observe. And if you've seen like a density tower, like in science class, where they put like a bunch of liquids like oil, milk, water in like a test tube and they all separate themselves by their density, and then you drop
Yeah.
different densities of objects and they equilibrate in different density gradients, in different density mediums. So that's
Okay.
basically what's going on. It's Archimedes' principle, right? This is what Archimedes and all the ancient cultures and things just kind of understood naturally. But they had to come up with a story for how we could possibly be living on the exterior of a giant spinning object when our first natural thought about that would be like, well, we would be flying off it if we're on a giant spinning ball. So they had to come up with a story as to why we're like stuck to the ball. And they've said
So you're saying
we're being,
they invented gravity?
well, no, I mean, gravity, if you're just calling it the observation of an object rising or falling, no, of course they didn't invent that. That's just a natural phenomenon. What they invented was a theory that said you're attracted to the density of the ball Earth, or is the bending and warping of space time that's keeping you in this position, not floating away off of a spinning ball. That's what they invented. So that anytime you hear the word gravity, you're thinking about being stuck to the exterior of a spinning ball. It's like
Yeah.
word magic, yeah? Whereas that's not the case. So, whereas they've told you that it's like you're being pulled down, I would say it's more like you're sinking in the medium of air, right? So when you jump up, it's like you're jumping in the medium, but then you sink back down. Just like in water, if you were to wear weights, you sink through the medium. It's not that you're being pulled by the density or the mass of the earth. You're sinking through the medium because you're more dense than the medium. You understand that?
Yeah. I get what you're saying. Yeah, I want to.
They call it gravity. They call it gravity because it's actually called specific gravity. If you Google specific gravity, you're going to get what Psyclone told you, Archimedes' principle. So there's different types of gravity, but everybody just uses gravity.
Yeah, there's loads of different theories of gravity. This is why we've got these mad stories like the bending and warping of space-time, which is total imaginary conceptual nonsense. But the reason we have that is because they're having to come up with a story as to how it could even be possible that we could be living on the side of this giant spinning ball. And so they have to come up with a story.
So where do you stand with, I guess, astronomers, like looking through telescopes and whatnot? How do you feel about, seeing all these like celestial objects and them appearing as balls, or like, do you feel like maybe that they would just be discs, or that they're potentially
No,
flat
not
as
quite,
well?
not
Like,
quite.
where do you stand
So
in that?
Well, so the luminaries, what I would say is
Yeah.
there's a big the big difference is in modern astronomy, they are presuming under the assumption that they're balls of gas and rock in a giant vacuum. Yeah, I don't
Yeah, but
believe
we've
any of
seen
that.
them, and there's like they look like circular from like we've seen them
Circular
when you
may
can see
be, yeah.
Mars. You can see
Circular may be, but we don't know that
almost
they're
spherical.
spherical objects. No, we can't define them as spherical
So you think
objects.
they're just at a perfect angle where they look like a disc and they're all facing us?
Well, they're called in astronomy. They actually refer to them as disks, the disk of the sun, the disk of the moon, right? Because that's actually, strictly speaking, what's observed. Yeah, because especially when you're looking through a telescope, it's a monocular. It's a single lens, right? So you can't define a 3D shape like a sphere from that distance with a single lens. So literally, you are just observing a circular object. Now, that doesn't mean I'm saying it's a circle or a sphere or not. I'm not making a claim, because to actually claim what 3D shape they are, if any, you'd have to be able to travel to them and around them and start to like look at them, which we can't do. So all we observe is these like energetic blobs of light in the sky. And now what I would say is they are not places to go to. They're not balls of gas or rock in a vacuum. It's more like they're hands of a clock. Right? The sky is a giant clock, and the sun tells us the days and the nights, the moon tells us the months, and the stars tell us the seasons, the time of year, right? Used for signs and seasons, basically, so that human beings know when to plant, when to harvest, this kind of thing. So I would say that they've taught us a way of thinking about the luminaries, which is totally at odds with what all human beings have ever understood about them, which is that they're not destinations, they're not potential destinations or things we can go to. They're simply there as a guide for us in terms of timing. Maybe some more things, but certainly they're not places to go to. And I think what they've done is they've taken man's natural explorative curiosity that he used to apply to the earth, and we used to explore the earth and do all kinds of crazy adventures on earth, and they've thrown the imagination into space, the collective societal imagination. They've said, hey, Mars is the place we can go to. Well, not you, just us, the government. So everyone's like given up on exploration and discovery on earth, and instead they just think, oh, well, the government's going to do it in space. I think that's the trick.
Well, I mean, you gotta understand, there's not really. So the whole, because a big part of it, an argument I've seen is like Antarctica is like this like layer, and that there's something beyond that. A lot of people believe, and it's all like walled off by military personnel of like NATO or a bunch of different countries.
Well, it is under international treaty, and it is controlled by a number of international navies. That's absolutely true.
Yeah. And how do you feel like about that? Like, do you think Do you think they're like protecting something, or there's something beyond that?
Well, I'm sure they are.
Threshold
I
there?
mean, they have to. Yeah, they have to be doing something because you don't just get 50, 60 nations agreeing that no one can go to Antarctica for no reason. And I don't
Yeah.
accept that it's because they care about the penguins, because I don't really think Russia and China and that have a great track record for animal welfare. So I don't really buy that. But what it is about it, what it is going on down there, I couldn't tell you.
Yeah.
I've never been.
Yeah, yeah. See, but I want to expand upon that though, because you're saying, you know, human beings don't want to explore. I feel like
Oh no,
space would
human
be the
beings do
natural
want
place
to
to look
explore.
towards in terms of exploration. I mean, we have all these like developed nations across the world. There is, I guess, like tourism. There's like visiting, but
In
there is
space,
no
you mean?
real like there
Are you
is no
talking about
real
space or
like
Antarctica?
I mean, I guess that there's not really much else. There's, I guess, the ocean. That's like the deep parts where it'll like crush every organ in your body, but there's not much else
Oh no,
to explore.
but what I'm saying is there is no. I mean, the medium that they're calling space to explore, I mean, that doesn't exist. So when I say they're sending the imagination, it's like a distraction from what could actually be explored, which is just the Earth.
Yeah, but what of the Earth like isn't is what I'm asking you.
What of the Earth
Antarctica
isn't
and
explored? You mean?
yeah, like
Well,
what
it's hard for me to
scares
say
you?
because it's like what is beyond the known territories? That's like that question. How would I know? Because they're unknown. So, I mean, a few years ago, they said that Japan just found about like 7,000 new islands or something like that. So people are still discovering new land. And that's not even talking about what's north or south, which is generally prohibited to public exploration.
And like almost like borderline uninhabitable for the average person that isn't
Yeah, yeah,
100,000
yeah. So
years.
especially in the south, it's like, you know what it
Just
reminds
doesn't
me
make
of?
sense to live there.
It reminds me of like an out of bounds zone in a video game. Like
Yeah.
when you get too far off the map, it's just like you'll die here in a minute. That's kind of like what it seems to me. But there
Yeah.
are accounts from older cultures who say there is more land. There's other things. I don't know. It's all speculation. It's interesting.
There's also a
My
limit.
point would be.
Sorry, I just
Sorry.
wanted to add, Wolf, Cyclone. There's also a limitation of our knowledge of the land masses and the orientation. Because if you know anything about cartography, Yoda's pretty well versed in this. The way that the map is presented to us is all based on longitude and latitude, um, basically referencing the sky. It's very hard to actually know the distances between places correctly. It's very inconsistent. So we're given a perception of the world, but actually, in reality, we have no way to verify these distances are correct, the orientation is correct. So there could well be other lands out there that we don't know about, and it could be quite easy to hide because of the nature of how they've done how cartography is done with longitude and latitude. So I just wanted to add that as well. We don't know as much as we think we do.
If that's the case, if there really is a disparity in like the distances, how can we say like just to go back to the horizon stuff? How can we say that's that the measurements we're doing, you know, on the boats there are entirely accurate as well? Then,
Because we're comparing that to the globe prediction, and we can falsify that. So that's not making a claim as to. Well, we're basically saying it's an optical limit, not a physical one. So it wouldn't necessarily define a physical limit, the horizon, right? It's optical, it's the limit. It's like a draw distance in a video game. But it's how our eyes work, right? Yeah.
Yeah, that's different. That's just trying to verify that there's a curvature at where they say that it should be, right? That's just a validation.
No, but there's still a
Or a
degree
lack of
of like
validation.
measurement going on there. Is what I'm saying. So
Well, yeah,
if
we can
like
measure how far the horizon actually is appearing, and then we can say that. Well, for example, we've got observation where there's like a guy puts a camera basically on the ground at 1 foot, and for a 1 foot observer, according to the globe model, it should be a horizon at 1.2 miles away. 1.2, right? But we can see the horizon over 10 miles away, right? And when we do the math on this, it changes the radius value from the 3959 that they tell us to like, what is it, 250,000 miles? So it's orders of magnitude off what the globe is claiming. So then even if you wanted to say, oh, well, maybe it's just a bigger ball, it would mean basically you're saying that the known territories are like 1% of what's actually out there. So whichever way you slice it, we don't know anything about this place.
If I could step in real quick. So latitude and longitude bake in curvature. They bake in the radius of Earth. So when we're presented with objects 10 miles away that are visible from 1 foot off the ground, and the 10-mile distance is a coordinate map distance based off of that spherical coordinate system, then by its own claim, we should not be able to see these objects. But we do, and we can see well beyond them, which means the curvature for that coordinate system has been debunked by observation. Yeah, it's a big problem.
Yeah, so the observations of the horizon and debunking the globe kind of only open the door to these questions about, well, how big is the Earth actually? How much land area is there? How much ocean area is there? It opens the door to those questions, but it doesn't give us an answer. We don't know the answer.